Hi grade 9s, today we are learning about reactivity. And if you're following along, this is lesson 1.8. Okay, now the goal of every atom is to have a full outer shell. So you can, again, anything in red you need to write down here. So every atom wants to have a full valence or a full outer shell. And this would end up making them chemically stable, if that's what they do. Therefore, all atoms are going to want 8 electrons in their outer shell except for hydrogen and helium, because remember, they only have one shell, right? One orbital, so they can only have 2. And if they have 2 electrons, then they also have a full outer shell. Now, in an atom, we have protons, neutrons, and electrons. Now, the protons do not move. Neutrons do not move. But electrons move. And we know these are found in the nucleus. And that's why they're not able to move. So a proton or a neutron cannot leave an atom because they're found inside the nucleus. Now the electrons are found in the orbitals or the waves around an atom. And so they do have the ability to move. And that movement is the reason why atoms are reactive, or whether they are going to react with other elements. So reactivity we can define as determined by the number of electrons in the outer shell of an element. Now the different families or the different types of atoms have different degrees of reactivity. So some are more reactive than others. Now we're going to go through a few situations here, a couple examples. The first one is group 17, so this is our halogens, and you would have learned that the other day when we went through the families. The halogens have 7 outer electrons. You can write this part down here. They've got 7 outer electrons, or 7 valence, and they are therefore very reactive because they only need 1 more electron to have a full outer shell. So if you look at all of these Bohr models of, these are all halogens here, they all have 7 valence, and so they only need 1 more. So what's going to happen is they're going to take an electron from another atom. Another group we're going to look at are the alkali metals. So again, you can write this down here. They have 1 outer electron and are therefore also very reactive because they only need to get rid of 1 and they've got a full outer shell. So for example, if we just look at sodium here, so just draw your attention here to sodium. That's a Bohr model for sodium. So if it got rid of that electron, okay, so if it donated or gave away one of its electrons, that outer shell would be gone. And you'd end up then with a full outer shell. So then sodium would be happy. And that's true for all of the alkali metals. If they get rid of 1 electron, they end up having full outer shells. Now, group 18 is our next one that we're going to look at. These are the noble gases, and they're very snooty, very snobby. They have full outer shells already, and therefore they do not react. So they do not mix with any other atoms. They stick to themselves. They are already happy all by themselves. So this diagram, we drew them, this cartoon, they draw them very proper. They're very noble. They're part of the nobility. Now, looking at the periodic, so turn your page over here, the periodic table. We know about the families and we know the outer electrons based on their position in the periodic table and what family they're in. So basically, I'm going to write the outer electrons on top here. So this first column, group 1, they've got 1 outer electron or 1 valence. So what that means, everything in this family, in the alkali metals and in hydrogen, they all have 1 outer electron or 1 valence. The second group here, the alkali earth metals, they all have 2 valence or 2 outer electrons. And then we're going to skip this section here. These ones are called the transition metals. You can write that in. So the transition metals sort of change, so we're not going to talk about those yet. But then we go to boron. These ones have 3, 4, 5, 6, 7, and 8, except for helium, of course, which has 2. So this is all of the valence here. This would be all of the electrons. So if we look at halogens, the fluorine family here, fluorine, chlorine, bromine, iodine, astatine, they all have 7 valence, for example. The oxygen family, the chalcogens, all have 6 valence, 6 outer electrons. Now, atoms will bond by either getting rid of their electrons or stealing them from some of their atom. sometimes they share electrons between them. So for example, the alkali metals and the halogens readily combine to form compounds. So I'm going to quickly just draw the Bohr model here for sodium. I'm not going to worry about what's in the middle. I'm just going to draw the rings here. So I've got 1, 2. So we've got 11. 4, 5, 6. Okay, and then my outer shell here has 1 electron. Okay, now I'm also going to draw chlorine. So chlorine has 17, right? So first shell, 2. Second shell, 1, 2, 3, 4, 5, 6, 7, 8. So I'm at 10. So then the third shell is going to have 7. So 1, 2, 3, 4, 5, 6, 7. Now, we've got an alkali earth metal, which is the sodium, and we've got chlorine, which is a halogen, which has 7 outer electron. Both of them want a full shell. So sodium has a choice. It can get rid of 1 electron, or it can steal 7. What do you think it's going to be easier for it, to get rid of 1 or to steal 7? Yeah, to get rid of 1 is going to be easier. Then we look at the chlorine. Chlorine has 7 valence. It wants 8. So it's got a choice. It can gain 1, right? It can try to steal 1, or it can get rid of 7. So what is chlorine going to choose? Yeah, it's going to choose to steal 1. So what we're going to see happen is this electron is going to be given to the chlorine. And now, looking at this, is the chlorine happy? It's got a full set of electrons around it. It's got 8 outer electrons, so chlorine is happy. Now we look at the sodium. Sodium, we got rid of that electron, right? So what that allows us to do is we can erase that ring, and now we look at sodium. Is sodium happy? Yes, sodium is also happy because it now has a full outer shell. So sodium is happy, chlorine's happy, and this is why NaCl, which is our table salt, this is why this bonds so easily and so readily. The alkali metal wants to get rid of 1, the chlorine wants to gain 1. So very, very happy romance, right? Now, based on where the periodic table, where the element is on the periodic table, that will tell us about how many electrons it needs to either get rid of or gain. So I'm going to just go back to this picture here, and we're going to just talk about each family. So the alkali metals, this is this group here, we talked about them already. They're going to get rid of 1 instead of gaining 7, because it's much easier to get rid of 1. Now, for the alkali earth metals, group 2, they can either get rid of 2 or gain 6. So they're going to get rid of 2. Then we're going to go over to boron. They can get rid of 3 or gain 5. So it's going to be easier for them to get rid of 3. Now the carbon family is different, right? We've got 4, so that's right in the middle. So for this one, they can do either. They can get rid of 4, gain 4, or they're going to most likely share electrons there. And honestly, you'll talk about that in your grade 10 chemistry course, so I'm not going to go too much into the sharing there. Nitrogen, if we look at this column here, they all have 5 outer electrons or 5 valence. So is it easier for them to get rid of 5 or to steal 3? Yeah, so they're going to steal 3. Oxygen family, they're at 6, they're going to steal 2. Halogen's going to steal 1. And then, of course, the noble gases don't react at all. So looking here, how you do this, you're going to find sulfur so I'm looking at this first example here, sulfur, so we find it, and I'm just going to put these numbers on top here again. Okay, so I know that sulfur has 6 outer electrons. I'm going to write 6 outer electrons, and it's going to gain 2 electrons because it's easier for it to gain 2 than it is for it to get rid of 6. Okay, next example, we'll try lithium. So we find lithium. It's got 1 outer electron. And what's it going to do? It's going to lose 1 electron. Next, we're going to find calcium here. And again, so here we've got 2 outer electrons. And what's it going to do? It is going to lose 2 electrons. Good, so hopefully those were easy for you, because this is what your assignment is based on, these concepts here. But we're going to do this last little bit here. So put the following elements in order of reactivity. So oxygen, neon, fluorine. So let's go, so least reactive to most. So out of these 3, oxygen, neon, and fluorine, let's change our color here and circle them on the periodic table. So we've got, oh, that's not a good color. Let's go blue. We've got oxygen, neon, and fluorine. So the 3 in a row here. So right away, I'm going to ask you, which one is the least reactive? And hopefully you will figure out that it's neon, because neon is a noble gas, so it already has a full outer shell, doesn't want any more. Okay, so the least reactive is going to be neon. But then between oxygen and fluorine, which one do you think is more reactive between those two, between oxygen and fluorine? Now, oxygen needs to steal 2, fluorine only needs to steal 1. So which one will be the most reactive? Yeah, it's going to be the fluorine, and then oxygen is in the middle here. So the fluorine, because it only needs to get 1, that makes it very reactive. So it can easily pick up an electron from some other atom there. Okay, so your assignment today is to do the worksheet on understanding how and why elements bond, and we'll correct it next time you're in class. Thanks, everyone.